This meeting is being recorded.
In Chapter 13, Section 7, we are going to review how to name something called an epoxide or a cyclic ether. So for cyclic ethers, the ring size, so whether it's a total of 3 atoms, 4, 5, or 6, like we see here, will determine our parent name. So most of our discussion, we are going to focus on a 3-membered ring, which is called an oxyring ring system. These are also known as epoxides. So this will be the focus of our discussion in this section on cyclic ethers. We're going to stress the epoxides, and we're not really going to see these other 4, 5, and 6-membered cyclic ethers throughout our discussion. So let's take a look here about these epoxides and some common molecules that we can see in this form. So as noted here, an epoxide can have up to 4 R groups. So obviously the oxygen here does not have an R group, but either carbon in our 3-membered ring system can have either a hydrogen or an R group. So this would be considered a substituted oxyrane, aka an epoxide. And over here we see our simplest epoxide. We could call this ethylene oxide. Through one of our nomenclature routes, we'll see that there's a couple different ways that we can name these epoxides. And down here, we're shown that even though these are unstable compounds, they can be found commonly in nature. So some sex pheromones down here. So we have this female gypsy moth, and we see right here that we have an epoxide. And then we can even have multiple epoxides or cyclic ethers found in the female American cockroach pheromone over here. So again, they are unstable, but they are commonly found. So how do we name these? So there are 2 methods. So the first method, we treat the oxygen as a side group. So what we would do is find our longest carbon chain, which includes the oxygen as a side group. So we have here numbering 1 through 5. We would find that this would be a pentane parent, and we would name it as an alkane since there are all single bonds. And then we would name between carbon 2 and 3, we have an epoxy side group, right? So we name where the oxygen is connected to which carbons as an epoxy. And then we also have this group here and this group here, which we would name alphabetically. So on carbon 3, we have 3-ethyl, and then on carbon 2, we have a 2-methyl substituent. So if we put all this together using this naming system, this method, we would have a 2,3-epoxy, 3-ethyl, 2-methyl pentane. Now, naming that same compound differently, we could use the oxyrane as our parent. So the 3-membered ring here would be our parent, and we always number the oxygen as our atom number 1. So we have 1, 2, 3. If we had a less substituents on one carbon versus the other, we would name that one first because we want the lowest number of our locants overall. So what we see here is that on my carbon 2, due to alphabetizing, right, ethyl would come first, we would number this carbon 2. So we have 2,2 diethyl, both ethyl functional groups or substituents there. And then we have 2 methyl substituents now on our carbon 3. So 3,3-dimethyl oxyrane. So we put all this together, and the same epoxide using this naming system will be called 2,2-diethyl 3,3-dimethyl oxyrane. So both systems are commonly accepted, and you may see one or the other or both in future quizzes or exams.